Hi, I'm Kathy. I'm from Microsoft for Startups, coming to you from Sydney. It's really, really awesome to have everybody joining today. We've got Simon Waight with us. We will sort of introduce the topics in just a few minutes as more people join, so that everyone knows that they're in the right spot, the best spot to be at this particular moment in time. And it's going to be a really cool session. So thanks for being here. I can see. Yeah, probably get started now. So today we have Simon Waight, the Azure Pro Developer Lead in Sydney, also going to deliver us a session on containers and serverless, 0 to 100 in 30 minutes. Gosh, we could have called that the fast and the serverless, 0 to 100.
Oh, Kathy,
we'll tweak it.
You should have told me that. I would have changed it. That's
well,
awesome.
there's like 7 sequels of that, so heaps of opportunities going forward.
There's about that many ways to run containers in Azure, so it would have been appropriate.
That's a hook. All right. Well, today is going to be a really awesome overview for everybody just wanting to get started. Simon's not going to go too technical, but just technical enough so that everybody here gets a really good idea. Some demos, some high-level demos as well, so that you can see it working in real life. Simon is a great person to be delivering this. He's got years of experience spanning software development, infrastructure, architecture, and IT operations. And I think a lot of people probably already know him here and have followed him from different webinars that he's done in the past. For those of you that are here for the first time, you're in for a treat. So I'm going to hand over to Simon now to take us through the session, maybe a little bit about how he's going to structure it, tiny bit of housekeeping. The session's recorded. So if for any reason you wanted to share this with some of your team, revisit it later, it will be available up on our YouTube channel. If you'd like to get in contact with me about the Highway to 100 program or Microsoft for Startups program, I'll drop my email into the chat function. We will divvy this up into about half an hour, 40 minutes for Simon's presentation, and then afterwards we're going to freestyle with some open forum Q&A, which is an excellent opportunity to pick Simon's brain. And if there's a big Q&A overflow, Simon is happy to open a sort of a blog or be contactable afterwards. So sky's the limit, guys. Enjoy. Over to you, Simon.
Thanks a lot, Kathy. Appreciate that intro. It's always a tough ask to live up to the intros after they're like that. Let me just quickly start by sharing my computer screen here and get the right screen. Hopefully that's the right screen. Excellent, that's the right screen. All right, so what I did want to do just before I start is I'm joining you today from Sydney, Australia. So first of all, welcome from wherever you're joining us around the world and whatever time of day that it is. I hope you and your locals are doing well in these mad times. But I did want to start by acknowledging the local people, which is the Gamaragal people here in Sydney, which is the traditional Aboriginal people whose land on which I'm presenting on from today. I'd like to acknowledge and pay my respects to the elders, both past, present, and emerging and future as well. I think it's important that we acknowledge our local Aboriginal people, and I welcome Indigenous people from whereverabouts in the world you're joining us from today. I'm going to do serverless and containers, 0 to 130. It's there on the screen. That's the goal I've set myself. By all means, while I'm presenting, I think you folks are all on mute as far as audio goes, but if you do have questions, please do put them into the chat and we can use those as a conversation starter. I am interested in probably doing a high level as quickly as I can so we can get to the question section of today, because I think that's actually more valuable than just me sort of blurting out a lot of content to you. But let's set some baseline expectations here. So let's ask 2 questions. What's the most important goal for a startup? Maybe you want to type some answers into the chat and see what people think that is. It's okay, teams can take everyone typing in at once, so go for it. no one types anything, it's going to be a very short presentation. So this can go deeper as long as you like if you put stuff into the chat. Assuming you have access to the chat, of course. Scaling up while impacting your present audience. Okay, one way to put it, yeah. And by the way, there's no wrong answer here. This is not a trick question. I won't do a magic reveal and go, aha. It's really just, you know, what do you think the important things are for a startup to achieve? All right, so look, the reality is that a startup doesn't exist to utilize technology. It's not a technology-driven reason to start a business. A business is there to solve a real-world problem of some sort. So ultimately, you know, the goal of a startup is really to hit revenue positive as quickly as possible. Build the best product that consumers will like, absolutely. And if consumers like your product, they're going to want to pay to use it. And if they're going to pay to use it, then you're going to build a successful and sustainable business, which ultimately is why anyone goes into business, is they see an opportunity to solve a problem and hopefully to allow themselves to make a living from running that business. So that's a good non-technical way to look at how we're going to approach today. Following question from that is, well, how do you think serverless and container technologies help achieve this goal? Again, no right or wrong answer. So, you know, take a punt. No one's going to think anything ill of you if you do pie in the sky as an answer here. Have a go, and maybe reflect on what I just said in that segment there. Less maintenance, yep. Deploy faster, okay. I think you guys have done this before. Help with scaling. Okay, have you seen my deck? Has everyone attended this presentation previously? Those three answers are actually really good answers. But ultimately, I think, you know, if we take technology as a general rule, they may or may not actually help solve your business problem. And really what I want us to reflect on today is we are going to be talking about serverless and container technology, but ultimately they may not be the right fit for your business or where you want to go. They absolutely have some advantages. But, you know, I think I see a lot of in the industry is people starting with a technology and then applying a business, trying to fit a business problem into that technology. You know, Kubernetes, which is a container parallel technology. When you do containers at scale, you use Kubernetes. I see a lot of people saying Kubernetes will solve this for us without actually understanding what the problem is they're trying to solve. So take everything that I present today with a grain of salt and as a way to inform your decisions as you progress the growth of your business. Absolutely, these technologies can help you, but they may not necessarily be the right technologies for your business. So what are we going to do today? I want to start with a couple of baseline concepts first, just so that we can level set and understand a bit more about some of the technology I'm going to talk about. We'll take a look at what serverless technology is, and then we'll take a look at what containers are, and then we'll have the really cool bit, which is the open Q&A, where hopefully you're going to bombard me with questions that I can't answer, which is awesome. So let's talk about hosting models. And I appreciate that pizza, a piece of pizza maybe is a bit of an abstract place to start here. But I think if you've been around a while in the industry, or if you're a founder, you've maybe been doing research into how to start and grow your business in this modern cloud world, you may have come across a bit of a fun diagram called pizza as a service. Now, it's been around for a while, and there are multiple versions of it out there. If you go and look it up on Google or on Bing, you'll find multiple versions of the diagram. But what I wanted to do is I wanted to use just a sort of a vanilla Microsoft view of the world. So this is a little bit old. There are multiple versions of this that have a lot of different hosting models in there. But at a high level, those four items across the top, which is on-premises, infrastructure as service, platform as a service, and software as a service, are kind of the four guiding constructs that we talk about when we're talking about modern technology and hosting platforms for modern technology. When we talk about serverless technology, We're talking very much on the right-hand side of this diagram. We're in the platform as a service, or PaaS world. Some people break it out even further, and you'll have FaaS, or functions as a service, and serverless really fits in there because it even removes, in some cases, having to manage, say, your data and some aspects of the hosting environment. But as a small business starting up, you can imagine that if you're on the left-hand side of this diagram, you're on premises, you may be running in a shared data center, you may be buying and hosting your hardware in that shared data center space. You have to manage that entire stack, top to bottom. And this doesn't go down to the hardware layer. Like, there's a whole other layer of hardware that sits underneath this. This is really once you've got those machines racked and stacked, powered on and ready to go. Increasingly, what we see in the industry is we see businesses really wanting to push right on this spectrum because they want to reduce the amount of management that they have to do to maintain things like server patches, configuration, the types of frameworks that are maybe deployed to their machines. And they want really just to focus on solving business problems, which is where serverless and to some degree containers comes in. SaaS is the ultimate goal for a lot of businesses as well, which is I don't need to manage any of it. So SaaS services from Microsoft would be things like Microsoft 365 or Dynamics 365. And there are other well-known ones in the industry like Salesforce, for example, where you don't manage anything other than the data that you put into those systems. And then you may be able to do some extensions and integrations into those points. But today we're going to focus very much on platform as a service and maybe talk a little bit about infrastructure as a service. So keep that in mind as we go through the rest of this session. The other construct that I wanted to talk about before we get into what is serverless is this idea of application composition. And apologies if that maybe goes, one level down the pipe for your current knowledge, but I think it's important to talk a little bit about application composition. So what do I mean by application composition? So there's probably two leading constructs for this. One is the Monolith, and one is the Microservices approach. So traditionally, software was mostly built and continues probably to be built in the majority of instances as a monolith, which is a big piece of software that maybe solves a big business problem. So it could be, let's say, a loan origination piece of software inside of a bank, for example. That's built as a monolith. It does all of the things internally. Developers work on a big code base. Releases of that software happen all at once to have updates show up to end users. Increasingly, though, in a modern distributed world and a cloud-hosted world, we start to see the growth in microservices as well. So microservices, unlike monoliths, is represented by a series of discrete bits of code that serve one function. So you may still be able to build a loan origination system out of a series of microservices, but the goal with that system with microservices is to really decompose the loan origination system down into a much smaller set of steps that are written and developed and released and managed independent of each other, which allows you to have a much faster time to adding new features and less of what's known as a blast radius. If something goes wrong, typically it's going to be just with your microservice and maybe not the entire application, for example. So just a question to the audience. Which one do you think you can build faster with, you can update faster with more confidence? Do you think it's going to be on the monolith side, or you think it's going to be on the microservices side? Give you 20 seconds to type in the answer to that. Microservices. Good job. Yep, Jay's right. So typically speaking, we see microservices as the kind of the way forward. And I think for smaller businesses, they also make a lot of sense as well, because what they allow you to do is to build capability over time without necessarily having to build this, this behemoth application that you then have to go through development hell, adding new capabilities to over time. And let's face it, when you're first starting out in business, and it's a common pattern for many startups, is that you might come to a point where you need to pivot and change the direction that you're intending to go with your business. So, microservices, you could say microservices because it's clustered. Yeah. And it's also certain things like scalable, for example. Imagine taking a monolith that's a single big code base that might perform a lot of different actions, and then all of a sudden you want to take it to a modern cloud world where the way you scale to meet demand is by running multiple instances of that software, alongside each other. It's much harder to achieve that with the monolith than it is with microservices, where you may only need to actually scale out one or two components of your microservices architecture to meet demand, versus a monolith where you really have to probably move it to a much bigger single host to meet that demand. So microservices is the space that we really want to focus on, and it aligns well with both the serverless construct and the containers construct that we're going to dig a little bit more into going forward. How am I doing for time? 15 minutes. I've got 15 minutes or thereabouts to get this. So this is really just a generic definition of what serverless computing is. And really serverless is a computing construct that pretty much would not have existed without cloud computing, because really serverless is there to help cloud providers utilize spare capacity. And what it means to cloud consumers is that they can utilize that spare capacity, generally speaking, at a lower cost than if they have to reserve that capacity, and potentially at a much larger scale than if they are back in that monolith world. So with serverless, and the serverless term gets bandied around a bit. There are a lot of now databases that are listed as serverless. Really today, I just wanted to focus on serverless compute. So this is where you would write business logic code that executes in a fashion where, as a developer or an operator, there's no server for you to provision. There's not even a platform as a service plan for you to provision. You literally just deploy your code to a serverless node sitting somewhere in, say, Azure, for example, and then Azure will take care of allowing that to scale as demand increases, scale down as demand decreases, and then being able to manage things like faults and what have you. As you've probably taken from the previous slide, microservices is really the trend that we see, and serverless computing is really, really tuned to the idea of microservices. Because of the nature of the compute that gets used for serverless compute, you're really restricted in what you can do. So you can't write software that takes, gigabytes of memory, and hundreds of CPU cores. It's not really going to be suitable for a serverless compute construct. So the construct that you're choosing here really enforces, your application architecture to really make use of, single purpose or small, low number of purposes per microservice, so that you can best utilize that, elastic scale and small compute that you have available to you. So there's a Wikipedia link there, which takes you to the generic description of serverless compute, which would be good to go and have a look at. So serverless, let's talk a little bit about attributes of serverless for a second. There's, a very big trend in the industry towards no-code or low-code solutions. So in the Azure space, we have things like Azure Logic Apps or Power Apps or Power Platform, where, yes, you still need to select a plan, but ultimately you're not then controlling the growth and shrink of the compute that sits behind the scenes for that plan. You're just worried about your code. And we also have in the Azure space, we have Pro Code as well, which is where you're actually writing code in, say, a Visual Studio Code or in a IntelliJ Java development environment, and deploying that code onto some compute that will execute that for you. Because of the nature of the small amounts of code that you're writing, you can really introduce a rapid debug deployment capability into your software delivery, which means that you can be much quicker in adding new features or, in fact, fixing bugs as they arise. Serverless compute, generally speaking, will allow developers to write code in a language that they're familiar with, so you're not required to relearn the expertise that you've developed as a developer. You can bring that with you. So, for example, in the Azure space, you can write functions, Azure Functions, which is our serverless compute. You can write them using .NET. You can write them using Java, TypeScript, JavaScript, Python, and we actually give you the ability to bring your own language as well if you want to do that. They allow you to concentrate on the business problem, and the reason they allow you to concentrate on the business problem is because they have this idea of bindings, which allow you to declare a connection, say, to a database, and then a trigger, which is some event occurs which would cause your code to wake up, execute, call the database that you've configured, pull the record in that matches some value that was provided to the function in the trigger, do some processing of that data, and then potentially push that data back out to a destination, again through a binding. And those bindings and triggers really simplify the ability to integrate into multiple systems. So we see a lot of, say, logic apps and Azure functions used in systems integration scenarios where they'll be retrieving data from one system, performing some form of transformation on that data, and then pushing it to another system. So you'll see that a lot if you go down that route. As I said, scalability is taken care for you. You're not having to worry about, do I put 10 of these or 15 of these or 20 of these? I can say, well, I will start with 3, which allows me to know that I can deal with the sort of the background noise that my application might have to deal with. But then I can define auto scale rules, or say when I hit a certain threshold, scale out to this many number of instances as a maximum, so that I can control my cost structure, so that I'm not, blowing myself out of the water from a cost perspective. They're perfect for event-driven microservices solutions, and event-driven solutions are increasingly ones that we're seeing a lot of in the industry as well. And as I've mentioned, when you have less demand, you can scale down potentially to 0, where you're paying, less than a cent per hour to save, to store some data in a storage account, but you're not paying for compute costs at that point. And then they can light back up as the demand starts to come in. So you're only just paying for what you use. The term I like that I've seen used a lot here is PAYG, which is pay as you grow, which I think is a really good concept to have. All right, let's do a quick demo, because I think a demo will probably solidify some of this in your minds. You'll probably, hopefully, at some point have, say, uploaded a video into YouTube or Vimeo or whatever your local video hosting environment is. And when you upload that video, it's not immediately available to you on the platform. YouTube will say, okay, well, we're processing your video, and then the standard definition version will be available, then the high definition, and then at some later point, you might get the opportunity to play around with the captioning for that, and you'll get presented with, say, some thumbnails that you can, select from as the preview for your video. So what I thought I would do is, I've actually got a solution that runs and does a similar sort of thing. So what you do is you would have a website where a user uploads a video into the website. That video upload triggers a message, which is how we do event-driven programming. Is we have a message or an event that actually triggers our code to run, and that code knows that when it receives that piece of information that it needs to wake up, it needs to grab, in this case, the video file, needs to do some processing for it, and then it needs to write an output back to a storage account. So I've got a blog that goes along with this and some source code, but nothing speaks louder than a demo. So what I'm going to do is, here I'm in an Azure subscription. Let me just zoom in so you can see a little bit. This is actually a queue, and what I'm going to do is I've already uploaded the video file, and my video file is sitting in a storage account. Now, there are better ways to do this now. So we have something called Event Grid, where a file upload could trigger an event, and then our function could receive that event and process the file. But for the purpose of this demo, I'm using something I wrote a little while ago. This message is literally just going to contain the full address to this particular image, and I'm just going to submit that message. And then what will happen behind the scenes is I have a bit of code that's sitting already deployed in Azure in a function app. And this function is just written using Node.js, which is a common open source language. And I'm using an underlying piece of technology, which is also open source, called FFmpeg. And I'm using that bit of software to take the video, process it, and then produce a keyframe image that basically shows me all the keyframes in that video. So let's go and have a look to see if my function is executed. We can take a quick look at the code here. So I can't edit it here because I'm deploying it using a DevOps pipeline. but we can see that when the code loads, that there's not a huge amount of code in here. So if we scroll down, we've got less than 100 lines of Node.js code. This could probably even be less verbose than this. I'm not a very good Node programmer, but what I've done is I've now got a microservice that basically can receive any video that uploaded into a storage account and create a thumbnail for it. And at that point, I've done that in less than 100 lines of code, and it's scalable as well. So as I get more messages showing up in that queue, and I can't deal with them quickly enough in a single processor instance because processing video takes a lot of grunt, what will happen is that behind the scenes, Azure will go, okay, well, the queue has hit a certain length. I therefore will create one or more new instance of this function, and I'll start taking messages off of that queue and processing them on these other hosts. And then when that queue shrinks back down again, after a period of time, Azure goes, okay, there are no more messages, or the queue is shrunk small enough that I don't need some of these instances, and they will go away. So therefore, I'm not paying for that spare compute while it's sitting around. Now, let's go and have a look and see. So my storage account, I'll quickly show you the video. So don't be confused by the word over here that says containers. It's just a folder. That's what Azure Storage calls special folder at the very top. So this is my MP4 video file. Don't think it'll play from here. Let's have a look. Yeah, no, okay. So it's just literally a very simple sample video of a video called Big Buck Bunny. So that file's been uploaded, and then what I'm going to do is I should have now, after that function is run, I've now got this JPEG file that was created for me. And if I open this file, what we'll see is that FFmpeg has basically taken a video, which is about 40 seconds long, and then through the command that it runs, it's basically snapshotted every 5 seconds of that video and just created one big JPEG file for me. And now I could just keep uploading videos into the storage account, and their thumbnails would start showing up. And as I said, as I added more videos and more messages got created, then Azure would scale that out and my code could run. So I've got, in less than 100 lines of code, I've got a completely scalable video thumbnail solution that will take any video that I upload and process it for me. So that's pretty cool. Hopefully that's a good demo. And I think the interesting thing for this one in particular is I didn't cheat a bit, but I kind of combined both of the topics today. So FFmpeg doesn't ship as part of our standard functions host image in Azure. So I'm actually using container, and the container is what hosts my function code and that I customize using FFmpeg. If you go and have a look at the blog, and I'll post the link in let me just post the link in the chat window so you can go and have a look at that. It's a bit hard when it's embedded in a slide. I missed whatever someone was posting in the chat. Thank you for that. You didn't jinx me. How am I doing for time? Whoa, I'm not going to hit my 30 minutes. Close to it though. I'll keep going. So that was our demo. So just to summarize, why serverless? Shorter time to ship features. You can focus on your business problems rather than the code and the management of infrastructure. You can do scalable solutions from the start, even if you're not sure if that's going to be something that you need. You're not cutting that off from day one. And it really the construct really enforces you to focus on simplifying the code that you have, so that the solution that you deliver really is that less than 100 lines of code and having just a single purpose. Why Azure Serverless specifically? So focusing a little bit more on our platform. So we actually published a Forrester white paper called The Total Economic Impact of Azure Serverless. It's probably more focused on large scale enterprise, but there is some applicability here. And hopefully some of you will build a business that will become one of these large scale enterprises at some point in the future. The reason that people were talking about the benefits of working on our platform, you continue to pick up innovation from the work that we're doing on our own platform. So I can tell you for sure that the Azure Serverless capabilities that we have in 2021 are not the same as the ones that we had in 2016. And I can say not even the same as the ones we had at the start of this year. So, by betting on a platform like Azure, you pick up the ability to get new and innovative approaches to doing things without actually having to make that investment directly yourselves. Because of the scalable infrastructure, you can focus on, only having to serve the demand that's there. You're not having to pre-commit, to long-term contracts and what have you. So hopefully you're increasing your short to longer term revenue by not having to spend money that you don't need to, which is always a good idea. They found as part of this economic impact research that Azure Serverless specifically, and these stats apply to our platform only, I would note, they increase the efficiency of developers as individuals and the overall team velocity by 50%, which is pretty amazing versus other ways of doing technology. And the cost of compliance is reduced by 30%, and that's mostly driven by reducing the headcount required to manage that, because you're running on a compliant platform and you can put automations in place. You can trust that you'll be more compliant than if you were not going down this route. And in the large enterprise, they showed that the payback period of investing in Azure Serverless is less than 6 months, which is pretty phenomenal. And you're talking millions of dollars here. They showed that that upfront investment in going down this route is paid off fairly rapidly. So let's have a look. While we are using this for high bandwidth project like video streaming, the cost may be high by comparing to independent. So you would probably go to a platform as a service capability in Azure, something like Azure Media Services, which is a very specific type of platform as a service offering where you don't manage the infrastructure, but you pay basically for data transfer. So data transfer is always one of those things that sneaks up on people. Data isn't free. Particularly egress data out of any cloud environment will cost you money, and clearly the more you stream out of your environment, the more that will cost you. Ultimately though, you have some idea. We publish pricing on our website, and we have folks who know it really well. So you can always do some calculations to help you figure out what that's going to cost you, and then maybe what you have to charge your customer base to cover that cost, or how long you can bear to run at a loss with those costs, depending on what you expect your demand to be. So that's a good question. But in terms of Azure Serverless Compute and Azure Functions specifically, not really applicable here. I would suggest that you're not going to build a video streaming service on top of Azure Functions. You could do, but I'm not sure that it would be the right solution. All right, what are containers? How are we doing for time? Overtime, that's all right. I'll keep going. Not far to go. So containers are a little bit of an interesting topic to cover, because they're probably fairly abstract. If you're not working much with technology, the sorts of problems that containers help solve that have been around for a while in the software industry are probably fairly hidden from people who work in the business side of an organization. But what they're really good for is for helping reduce the complexity of dependency management when you're trying to pack a lot into a small environment. So you would, for many new businesses, you don't have a large investment to help you buy lots of compute, even in the cloud environment. So you really want to try and focus on minimizing your footprint. Now, traditionally, you might install lots of packages onto servers, and then you would run into issues with, you maybe have, say, FFmpeg, which we've already talked about, has some requirements for specific C libraries on your machine, and you might have another piece of software that you need to install on the same machine that needs other C libraries on that machine. So C is a programming language, and libraries deliver capability to program so that as an author, you don't have to develop it yourself. And that's kind of been a big problem in the industry for a long period of time. On Windows, you would know the term maybe DLL hell, but that exists on Linux as well, where you have competing libraries. And what containers are really designed to do is they reduce some of that challenge by basically saying, I want to take my, let's say, FFmpeg, for example, here. I'm going to create an FFmpeg container. That's going to include all of the C libraries that it needs. And I can go onto a machine that is a container host, and I can say, take this FFmpeg container, put it onto your machine, run it for me. I can then take another library or another bit of software. I can containerize that with its libraries. I can go to the same container host and I can say, take this container and run it on the same host. And because I am now containerized with my dependencies in that container, I avoid a lot of the challenges that I had traditionally in running those software items side by side. Not all of them, but some of them. The other thing that's really neat with container technology is the reduction in duplication. So you may be familiar with the concept of a virtual machine. Virtual machine is an entire copy of an operating system and then any application you put on top of it. Now you can imagine if you've got a virtual machine that has all of that operating system software on it, so Windows Server or Linux, and then you've got your application on top of it, and then you want to create, multiples of those. You've got all of that operating system plus your application that you need to duplicate every time. With a container, you only need to duplicate just the differences between yourself, your container, and the host, container host, which means that, if you've got multiple containers running side by side and they can share underlying resources on that host, then you get a much higher density of software that can be run on a smaller footprint, which for a new business is really important because you're reducing the amount of compute or the amount of storage that you need to run your business, all while avoiding some of the challenges of trying to pack all of that software into a single host. Very abstract. So let's talk a little bit about a real world demo. This might help make it a bit more tangible for you. Does anyone know what that is? Suraj, put your hand up, or their hand up. My apologies. Feel free to type it into the chat if you're unable to unmute yourself. Just type it into the chat. Give you 10 seconds. All right, so this is a Raspberry Pi. Raspberry Pi is a little bit of hardware. It's actually a super powerful tiny computer. It's about that big. Okay, it's probably a bit hard on screen to see. I don't have big hands, but it's not much bigger than say, let's say 10 centimeters by 5 centimeters at most. And this one here has got network cables and video connectors and all sorts of stuff on it. I have one of these in my house. In fact, I have multiples of these in my house because I like to do side hacks. Does anyone know what that is? Yep, it's a Raspberry Pi. Yep. So this is a piece of software that you can run on a Raspberry Pi. This is called a Pihole, and a Pihole is a way to avoid having to deal with a lot of adverts and stuff that are being pushed down onto your computer or to your local network at home, because it acts as a filter. So what will happen is your computer will say, go to a website. That website will have lots of third-party advertising on it. The Pihole acts as the address resolution host for your network. So when your computer looks up addresses, it goes to the Pihole. And the Pihole returns, I don't know that address, for something that might be an advertising website. So it's a good way to reduce the amount of traffic coming down to your home network and avoid getting lots of advertising appearing on your machine. Now, you can take that Pihole physical device I showed you, and you can run this software on that. Now, the problem with that is that you've got to have that hardware. You've got to know what you're doing with it. And then you have to maintain the Pihole software itself. So it's not a difficult process, but if it's not something you're familiar with, it can get quite challenging. This is a Dockerized version of that software. So someone has said, okay, well, I'm going to take the Pihole software and its dependencies, and I'm going to create a Docker container image for it. So Docker and containers you'll hear those two words a lot when you're talking about containers. Docker is a business that's probably by far the best known in the container space, but a container is a generic concept. So a Docker container is effectively just a container, and Docker provides some really good tooling around the outside for managing containers and allowing developers to build container images. So Docker Hub is an open container host, container hub, where you can go and pull these images. So this image contains everything I need to run a Pihole on any host that can run Docker. So I could run this on my PC, I could run it on, say, on my Android phone. If I could run Docker on my Android phone, I could run a Pihole on any device that can run Docker container. Now, I happen to have one of these. I've got a NAS sitting at home, a network attached storage device, which does some backup and other things for me in my house. And I thought, well, rather than run a physical Pi device, Raspberry Pi device, could I use this Synology NAS to run a Pihole for me as a Docker container? And the answer is yes, I can, because Synology ships a Docker host on their NAS, which is amazing. So on my NAS at home, I actually run two containers on my NAS at home. One is the Pihole, and the other one is a bit of network management software. Now, the same for the network management software. I can buy a device from the network device manufacturer that runs that software, or I can pull a Docker container image, which is the exact same software that runs on that hardware device, and run it on my NAS. So I now have removed two physical devices from my network at home, and I don't have to manage those devices. I have one place to go to manage them, and I can run them without any problems with them clashing with each other or overutilizing resources. So Docker and containers are a really great way to achieve this. So if you think about this in the microservices context, I might have a microservice that does payment management. I might have a microservice that does address checking. I could write those as microservices. I could create containers for each of those, and then I could deploy those side by side on the container host, or I could deploy them across multiple container hosts and not have to worry about them clashing with each other. And I can allow developers to work on one or the other, independent of the other person. So you can see that that kind of containers and serverless construct is really good for that, that level of separation. All right, one more demo, and then we'll talk about the value of containers. So hopefully everyone is familiar at least with the brand GitHub. So GitHub is a place for developers to collaborate when building software. For a while now, GitHub has had available a service called Code Spaces. I think Code Spaces are really cool, and I think it's very applicable actually to the startup world. You know, developer productivity takes massive hits when you have to download and install all of the stuff on your machine locally. But what about if we didn't have to do that? What if we could utilize someone else's compute to do that and provide it in a way that means I don't have to spend a lot of time setting up that remote compute? I can literally hit a button and I have everything that I need to do my work. So you'll be unsurprised to hear that the way Code Spaces is delivered is using containers. And we actually have extensions. So you'll see over here on the right-hand side for this repository that it's actually talking about Visual Studio Code remote containers. So we actually allow you to use Visual Studio Code on your local machine. So you get all that goodness of responsiveness from your local machine, but it can connect out to a container that's hosted either, it could be locally using dev containers, or it can be remote using the Visual Studio Code, the GitHub Code Spaces. So what I'm just going to quickly do is I'm going to come up here to this code button. Now I could do local, which allows me to copy that down onto my local machine and start working locally, or I could go to Code Spaces and I could say, okay, well, I'm going to use this branch here. And then what's going to happen is behind the scenes, now I've already run this once, so I chose the type of host that I want to run it on. And what will happen is GitHub will say, okay, I'm going to take this repository. There's a bit of configuration attached to this repository that says what it needs. And I'm going to start this Visual Studio Code this GitHub Code Space here. So if you've seen Visual Studio Code previously, this experience will look fairly familiar to you. It's actually Visual Studio Code hosted in a browser, but the compute that's doing all the back-end processing for my code, which allows me to run and debug my code, is all hosted up in GitHub in the cloud, and it's running inside of a container. Now you can use this technology outside of GitHub if you want, using dev containers, and the benefit here is that your productivity for your team is going to be amazing because you can avoid a lot of issues with adding new people to your team or changing people between working on components in your software. So you address a lot of challenges there, but that's all being delivered through the power of the container on the back end. And behind the scenes, GitHub is probably running thousands of containers on thousands of hosts inside of their environment, where each of those containers is going to be running a code space. And I don't see anyone else's code space, so I get that benefit and GitHub doesn't have to, build 60 million data centers to be able to host that. So that's just a quick demo, and we're almost done. Hopefully that's helped sort of solidify, containers and what they are and how they can help. So why do you want to build with containers? They're an open specification. So there's actually a thing called the Open Container Initiative, or the OCI. And if you build a container image that's OCI compliant, and you've got a hosting provider like Azure that provides compliance services, you can run that container on that service. So a lot of people, when they look at containers, talk about platform independence and the ability to choose where you want to run it. There are some asterisks to go along with that, because typically you're dealing with things outside of just your container workload. But the theory is a sound one, is that once I've got a container image, I can run it anywhere that can support container images. Reuse is built in. So the way you build containers is you say, from this container image, create the my container image based on this one over here. And then I can do that across multiple layers. And even as a business, I could build my own base container image and then have everybody else in my business that's building software use that as their base image. And I know that I've got a consistency going on there. So I've got reuse built in from day one. I'm not having to reinvent the wheel necessarily every time. And you see that a lot with even Azure Functions, which I talked about before. They provide a bunch of base container images that have all of the Azure Functions components already deployed into it. So all you need to do is to customize it when you want to use it. As I said, reduces those impacts of one bit of software impacting another when it's deployed onto the same host. It doesn't solve all of those challenges, because you can still have inconsistencies between container hosts and container images, but it does reduce the likelihood of that massively. They're immutable. So once you build a container image, it can't be changed. You can change the configuration of the software that's running inside it, but you can't actually change the contents of the image. Or if you do, the next time that image is deployed from wherever it's been built from, it'll be overwritten. So what it does is it starts to push left in your development lifecycle as a business, the idea that people don't want to fiddle with stuff that once it's deployed into production, which is a massive issue in a lot of businesses. You don't have to start with containers. You can actually add container technology to your stack later. So you could say start with Azure Functions deployed onto the Azure Serverless stack. Later on, you can choose to containerize that Azure function and run that Azure function anywhere effectively, whether it's on-prem, on the edge, in Azure, or in another cloud if you wanted to. And containers are really developer friendly. The technology to help developers work with containers is massively more useful today than it was even 3 years ago. It's very easy to add these into any developer lifecycle. And it really, has the impact, as we saw with GitHub Codespaces, of making, developers' lives much easier to quickly develop and stand up software solutions. Why Azure for containers? So, and we're almost done. Same for serverless. We continue to invest heavily in the container space. In fact, we just launched Container Apps, and we have one of the founders of the Kubernetes project who works for us in the Azure business. So you benefit from our continued investment in this space without having to do the heavy lifting yourselves. You have a range of choices in Azure. You can run something as simple as a Azure Container App. And when you get to be a large, successful business with maybe thousands of containers, you'll probably need an orchestrator like Kubernetes. We have that for you as well. So you're not locked into one mechanism to deploy. We can meet all of your dev and DevOps requirements. So we've got that kind of end-to-end ecosystem that a lot of our competitors don't have. And we're a software business by history. We started delivering software. That's how we started as a business. And I touched on it briefly before with the that compliance component around serverless. You can leverage our platform's compliance as a way to meet compliance that you might have in the industry that you're focusing on. You still probably need to do a level of compliance yourself to make sure your business is compliant, but from a platform and hosting perspective, that we've got your back covered from that. And then I think the last one, this is a bit of an advanced topic, is a lot of people oftentimes worry about vendor lock-in. With Azure Arc, we're increasingly allowing people to have the freedom to choose where they want to run their workloads, but have a single way to manage those workloads when they're deployed. And consistency of management is huge once you get to be a certain size business. And it probably pays to think about that fairly early on before it becomes an issue, because sometimes it can be hard to deal with it once it's already an issue. Word of caution, containers don't suit all users, as does serverless. It's not the case that these will solve all of the problems that you'll have. Containers aren't suitable for GUI or desktop type applications. They're really suited to server-side APIs and website style applications. Performance intensive workloads can really have some challenges with containers because of the way they do operating system level virtualization. So if you have something that's maybe going to be super intensive, maybe using a lot of graphical processing, doing a lot of heavy duty maths, then maybe a container isn't the right place to go, or you may need to bear the cost of running bigger container hosts than you planned for. We do have Windows containers. Microsoft's worked really hard on that. It's maybe not applicable for this audience because you may be building a net new business from the ground up, but Windows containers don't suit older Windows workloads. So you really need to be building a modern, probably Windows Server 2019 or above Windows-based application to be able to use containers in that space. If you're going to do multi-container, which you probably will do at some point, trying to run those without an orchestrator of some variety is probably a recipe for disaster. So you probably will end up having to invest in building the capability in your business to manage and run Kubernetes. And that's kind of become the orchestrator, de facto orchestrator in the industry. It's not the only one, but it's by far the one that most people have kind of orientated around. And I would say, even if you've come or have people in your business who've come from managing virtual machine-based environments, whether they be small or large, managing container environments is not the same as managing a virtual machine environment, because it's kind of another level of complexity on top of that, particularly when you start to get to scale. So just a few cautions there. And with that, I'm well over time. There we are. I didn't quite do it in 30 minutes. So look, I'm happy to hang around, answer any questions. I'll have a bit of a scroll back through the chat and see if there's any questions I can answer. But otherwise, by all means, feel free to ask away while I just have a quick scroll through the questions.
Shrajesh, I think it might be a good idea to unmute so that people can either use their microphone or ask in the chat.
Yeah, hi everyone. So the floor is open for Q&A. So I have unmuted you, and also you can turn on your camera and shoot your questions to Simon.
Just while we're waiting for anyone to grab questions, Simon, any quick examples of, say, a startup that would use a container and one that would use serverless? Is that easy to kind of do, or is it super specific?
It's a good question, actually. Look, as I said, I think containers. If I look, I'm just trying to think how I would answer this. So if I was if I was a technology leader in a startup today, and someone asked me that question, I think some of it would depend on what I'm trying to achieve. So if I want to do purely event-driven integration, or even APIs, because even an API or application programming interface like a RESTful API, even those are event-driven. They're event-driven by a request from a third-party piece of software or a browser. If I'm doing that event-driven style of programming or event-driven style of business, then I probably would err more towards serverless, pure serverless. As I said, it's not an either or. You can then take that serverless and put it into a container, because a container ultimately is just a deployment mechanism for a piece of software. You can still write that software without having to containerize it. Where containers really have their advantages in the operation and scale of software. And as I said, if you want to, maybe you have a business that is, if we go back, let me just go back just quickly here to, just bear with me a second. So if we go back to our pizza as a service hosting model, So if you have a business that is, you know, probably more over here, maybe traditionally your business has come from, or the people in your business, the technology people have come from more of an on-premises infrastructure as a service style of operation, and maybe that's the way you're building. Then maybe taking the next step would be into what we call cloud native, which is containers. So you take the existing software that you have and containerize it, which gives you the ability to maybe reduce the amount of compute that you need when you're not seeing a lot of load for your business. I think if you're building net new today and you're not 100% sure, then you probably would start, I would say, with native serverless, and then potentially later on take that to a containerized model to give you a bit of flexibility about maybe where you can run that workload. You know, I think some of it would depend on what your business problem is that you're trying to solve as well.
Yeah, cool. Really good to know that they work hand in hand, and that it's not sort of one way or the other that's the right way. It's you know, it's what suits you at the time.
Yep. Let's have a look. I'm just going to have a look through here. It doesn't look like there are any specific questions other than the high bandwidth video. Either I did a really good job or a really bad job of describing it.
Definitely a really good job.
What I'll do is I'm just going to quickly chuck that back up. My details are here. You can get me on email, Twitter, or at my blog. By all means, if there's any questions that come to mind after this session, feel free to hit me up on any of those channels and I'll do my best to answer them. I appreciate, as a business founder, some of these concepts may not necessarily have direct currency to you, but I would say that you know, when and if you start working with a technical founder or technical lead, it's good to be informed about, you know, two of what are really the, I guess, the really hot concepts in technology and software development at the moment. So I think hopefully that's armed you with some good insights. All right. Any questions? Someone wants to see the demo again? Want me to go back to the code space and have a play? Let's use a few minutes to do that then. I'm just going to, well, maybe we'll wrap up with just a bit of the code space demo that I didn't get to, just to maybe make it a bit real. So this is a very simple bit of code. If I just open the main code here, see if I can zoom in on this. This is written in Python. Python's a programming language. Literally all this application is doing is it's using a very simple web framework called Flask. And then what it's doing is when it receives a request, so it's a website, when it receives a request at the root of the website, it's actually returning a static file, which is bundled into this application. So we would find, if we went in here, so there's static, we'll find index.html here. So VS Code can do this. Let's just add this to make sure that I'm not pulling the wool over everyone's eyes. Save that. So this isn't on my local machine. This is living up in the cloud somewhere. I don't exactly remember where I actually chose this to be deployed from. Now, you might go, well, that's nice. It's up in the cloud somewhere. How do I actually test this website? Because normally what a developer would do is they'd start a debugging session on their local machine, open a web browser, and then view that. But I can't do that because this is running in a container somewhere up in a remote region somewhere. I may not even know where that is. So what I'm actually going to do is let's see what happens when I debug it. So, and you'll see here, I also have now the ability to check this file back into this repository. So I've got that full developer lifecycle already happening without having to run anything locally either. But I'm going to debug this. I haven't had to install Python. I haven't had to install Flask. I haven't had to do any of that stuff. I don't have to have a web server running on my local machine. I'm literally just using this. So let's see what happens when I do this. That's going to run. Okay, so that's running. Okay, and then what I should be able to do is it's running. I have this set up. Where are we? Ports, there we are. So I've already run this previously, and what I've done is I've actually set it up so that it's the port, which is the web port, is actually port forwarded. So what I can do is if I click on this link, it's going to load. It's probably loaded in another window somewhere. All right, let's copy it up. It's opening up there. Thanks for that. Let me just try that again. Could be that I need to add a new port. So let's just delete that, forward a port. And port was 9,000. So let's forward that port, 9,000. Okay. And then I'm just going to copy that link again. If it loads this time. There we are. Now that you'll see there that it's got a very magical long random name, but I haven't had to install anything on my machine. Now, if I shut this down, so I'm just going to stop debugging. That port should go away. So if I try that, it should get an error back out of that because the debugging session is no longer running. Yep. So that'll eventually time out. That's fine. I can check this file back in. Check that in. Yep. Now I'm syncing it because my code space is a copy. I'm just going to sync that, which pushes it back into the main repository. And then what I'm going to do is I'm going to go to my repository, and I'm exited my environment. Eventually, the code space will spin down on the back end. The next person who comes along, or somebody else actually can spin up a dev container as well without impacting my code. So we should find, if we have a look in the static here, we'll see that there's my change committed. And I could, someone could download and work on this locally. Someone could have Visual Studio Code running a dev container locally. So you can see I've got a .dev container folder here. This has got my configuration. You'll see there I've got a Docker file, which is how we define our container image that we want to run. And then we have a little bit of additional configuration called devcontainer.json, which is what Visual Studio Code or Code Spaces uses to spin up things like environment variables and what have you for us when it starts. So that's the power of containers. Like when I started my career, if I'd have had that, in fact, I can see even today for some of the customers that I've worked with regularly, this would solve a whole raft of problems for them. Just because the amount of lost time and energy that goes into that experience that I've just created remotely is quite phenomenal, particularly once you start to get into complex solutions. Alrighty, so I'm going to stop sharing my screen. Hopefully that was a good overview session. I appreciate everyone sticking around. I give sort of 5 or so more minutes max for questions. If we don't get any questions in the next sort of minute or so, we might wrap it up there. But happy if you've got any questions, please come off mute or put them in the chat or ping me afterwards. The only bad question is the question you don't ask. At least that's what my dad told me. The next time I do these sessions, I'm going to ask Kathy to give me the title, The Fast and the Serverless.
Amazing. Well, if I can just come up with a title and then you deliver an amazing session, I'm happy with that split.
I'm not sure how comfortable I am with that. Do I get to at least choose the topic first?
you threw it out there. I just picked it up.
So I'm happy. What I might do, Kathy, as well, is I might share the slides with yourself, and then they can be shared with the community however you like. There's nothing in here that's proprietary. It's all public and open. So yeah, I'll get those slides to you so that we can share them with the great community you've got going on there.
Awesome.
Yeah, also I have posted Simon's email ID in the chat. So if anyone wants to reach out directly to Simon, you can write to him that email.
Definitely ask me about technology. Don't ask me about the programs and stuff like that, because I can't really help you with that. I'll direct you to other folks. But yeah, happy if you've got any follow-on questions about any of the tech we've talked about today or anything generally about Azure, hit me up. Didn't quite hit in 30 minutes, as always. Was to,
well, actually, I took up a little bit of the time at the start, so you hadn't factored that in, and you know there was absolutely nothing that was too much, too little. It was the perfect amount for what we needed to understand about actually a really complex topic that can take a whole lot off people's table, but if they understand it, save a lot of time, but also really level up and elevate a startup. I also want to say that for those of you that have come in from other places, Simon is quite active in Meetup, along with a lot of our other Microsoft presenters. And there's stuff around containers and sort of periphery information. So if you're just starting out and you would like to know more and have a look at the other kinds of education series sessions that we do, jump onto the Reactor Meetup and have a look, because you know, it can go more into depth or on different topics, and the more you know, the better. Absolutely, the only bad question is the one that you didn't ask. But you know, if you can kind of be filled up with more questions, then you're doing well. Mm-hmm. So just the last bit of housekeeping is that, yeah, Simon's going to send me through the slides, which is ace. If you want to share the recording, it will go up onto the YouTube channel, and you know, I'll hand over to Simon once more to give another minute or sign off or whatever you think, Simon.
Oh, that's all right. I'm not going to dance. That's just embarrassing if I dance. So look, thanks a lot, everybody, for your time today. It's been really great to have an opportunity to shed some light on these topics. Maybe I'll see you again in future. Take care. All the best. Wish you best success. And Kathy, yeah, if you want to wrap it up and we're out of here. Thanks, folks.
Lovely. All right. Couldn't have said it better myself. Thanks for being here, Simon. Thanks for being here, everyone. We'll see you next time. See ya.